You get the composite solid for today's class, okay? So here, you look at here, there is a notch of solid. This solid is have a big difference with the basic solid, yeah? We will found this one, we can found this one. So first one on the top is a cylinder, yeah? And the bottom one, the bottom part, we have found is a
Singular block.
yeah, is one kind of things. Prism, oh yeah, yeah, we have the prism, yeah, prism. So we combine two kinds of basic solid. So you can get this one, this one. How about this one? You can see, okay, we can use a yeah prism, use the cutting knife here, this cutting this direction and here direction and here direction or cut here. You can make this one, okay, you can show you. You can use this one to use cutting to get this one. So we call it composite solid. Means what? Means the solid is not belong to the basic solid, but is based on the basic solid to get the composite one. So just like here, we will found okay different kind of shapes, just like here. All of this one, so just like some equipment we use in the machines, just like use those equipment in the your car, yeah, your drawing car, you'll find a lot of items just look like shape. It is similar to this one, and also those kind of things we call those solid is not belong to the basic solid. Is a more complicated, more complex. So we call it a composite solid. Okay, so this one in Chinese means what? Means okay, all of this composite solid is by union or subtraction of the basic solid. So in this one we have two kind of method. One is union. Union means add them together. Union, yeah. And another one is subtraction. Subtraction. You cutting them and cutting into a different kind of parts, and you can use union or subtraction from the basic solid to get a composite solid. Okay. So here, look at here. We have a composite solid show in this picture. You can see. Okay, first when you look at here, okay, you can make this part this atom or just this composite solid into how many parts? You can tell me how many parts you want change them or just divide it to different kind of parts. You have any idea for okay how many parts you want to divide it this to into a simple one? How many parts you want to do? Okay, first you can okay this one is part. This one is part, and this is ribs, part 4, part 3, part 4, and this is cylinder. We have the hollow one. This is part 5, and also you have in the front you have another one. So we want to make this 1, 2, 3, 4, 5, 6. We want to divide divide this composite solid into 6 parts. So this one is union, yeah. Union means okay, we have 6 parts of different kind of solid. We'll combine them together, so we will get a more complicated, or we call it composite solid, yeah. So show you here is same thing. You make a 1, 2, 3, 4, 5, 6, all 6 parts. Then you move them together. Here also show you okay, we can change them into different kind of parts. 1, 2, 3, 4, yeah. So this is union, but this one we can use cutting or we call it subtraction. How can get a cylinder with a hollow? Because we have a cylinder, no hollow, so you use cutting. Yeah, you use a driller. You use a driller. Yeah, drill. Yeah, you can use a driller to drill a hole. To drill a hole, you use a subtraction, make a cylinder into a have a hole. Yeah, this is a hole, hollow. Yeah, you guys know this one. So hollow one. So you can use the cylinder, use a driller, drill a hole. Then you get this one. Yeah. So we call it subtraction. So in this picture or in this slide, show you guys remember this one is very important. We use the two kinds of major method to construction a composite solid. You know, so basic on a basic solid or different kinds of basic solid. Use union or use a subtraction or use both of them. Sometimes we use most of the times we use both of them. Combine them together and cutting something, you get a composite solid. So you guys maybe know, okay, why we use the composite solid? You should know that when you construction a building or just you want to design, just we can vehicle, drive a car. Yeah, in your cars, you you have to take a notch equipment, have different kind of shape, different kind of shape to make this shape is suitable to take the shape or just equipment to make your car more safe, more automatic, and more useful. So composite solid in the real life is very important than the basic solid. But when we know the basic solids, then you how can you use the basic solid to can get a composite solid? So they have the relationship between those two kind of things. So how can make them have relation? So we can use union and use subtraction or just a difference. Okay. Show you guys here. So this one is used subtraction. You use a prism. Yeah, prism. You cutting this part away, cutting this away, and cutting the top away, and you cutting a sideway into a slide one, into a slide plane, or into an inclined plane. Here you get this equipment. Yeah, because for the basic solid, we don't we have different kind of surface. Here we will show you some different kind of surface and how about the surface drawing in the projection plan. Just like here, we get the second part of the relation of surface of composite solid. Here we can see this one. Okay, you see here this plane on the vertical this plane and with this plane we have the because they have the different kind of position. They are not this plane and this plane, not on the same plane. Yeah, so you should have a we call it deflect. But this plane, on the ribs, this one is ribs, and the bottom one also have this plane. But this plane and with this plane have the same plane. Yeah, is on the same plane, so there is no line. When you do the projection, this line you should draw it. But this line, you do not need to draw it because they have the same plane. Just like here. You will find this plane, this plane, and this plane have the same position with the bottom side plane, the bottom part of the side plane, So remember, you do not need to draw a line here. Just like look here, because this is uniform. Uniform means all the plane 1, plane 2, and plane 3 they have the construction one plane, they have the same position for plane, so you do not need to draw a line here. Remember, if this 3 plane or 4 plane or 6 plane, they have the same position in the space, so you do not need to add the limits between these two planes or just like an intersection line of these two planes. Okay. But for the deflect, just like here you show this guys, you can see here this line. You need to draw just like the red line here because this is defect. If you move this plane on this direction, make the plane have the same position with the side one here. So you do not need this one. Remember, so uniform, no lines between the plane intersection line, but the deflect, you must draw the intersection line of this two plane here. And another one we call it okay, because for the deflect or the uniform means this two plane or this three or four planes are parallel each other. But if two planes are intersecting, just like here, this one and this one, so this line in this direction, if you draw it, just like here, you should draw a line here because this is intersection. You should have a line to tell me, okay, these two planes are intersection plane. Here, you should draw a line here. Yeah, you read one because these two plane not uniform because these two plane intersection. So you draw the line here. Remember? So remember these rules. Another one is also intersection. So intersecting. So this line, intersecting line should be shown in your projection. And another one is very interesting. For these two kind of things, we call it curve plane. Yeah, curve plane, not 2D plane. It's curve. The plane is curved. No straight line on this plane on the intersecting line. So, but if a plane, this plane is a curve plane, and another straight is a 2D plane, we call it or is planar plane. Yeah, planar plane, planar. Yeah, is a planar plane. So use tangent means what? Means okay, this plane the position just okay only to run through the cylinder and make a tangent position with this one. So you do not need add a line here because this plane and with this plane is tangent. Remember this one? So tangent means what? Means you all run through the cylinder just to cutting the most outside line. Yeah, here. You guys can show you, okay, 1, 2, 3, 4. We have 1, 2, 3, 4, four kind of surface with surface position relationship in the composite solid. Here, first we talk about the deflect. In this picture, you can see, okay, we call this plane and this plane. How about the relationship with the side plane and with this plane? This plane. These two planes are parallel plane, yeah? Are parallel plane. So these two planes are parallel. But they are not on the same plane. So you should okay draw a deflect line here. So this line you should draw it. Tell the construction plan company, you tell him, okay, there is intersection line here because these two planes are not on the same plane. Here you'll show you must have a line in two deflect surface. So you should have remember for deflect you should have a line. When you talk about if you cannot find if you cannot see the line, you remember this one and this one is this part, yeah, on H, and the bottom cutting part is on this dash line. Okay, two dash line. So in the middle two dash line means the cylinder is hollow hole in the and this cylinder, and in the bottom we have the outside two dash line. We are in the bottom we have a cutting a hole. So here if you cannot see the part, we use a dash point. But this point dot and the dash line. One dot point and the dash line we call it for the this means this two part are mirror position. Okay, means this line make the part two part the same part. So this one is for the always for the revolving solid, where we means this line is a revolving line. Yeah, you revolving this line, you get a hole here. So we should point and line and point, line and point and a dash line. One point and dash line. Okay, this is a dash line. The difference for the dash line, this dash line is it represents a line you cannot see, but it exists in the solid. Because if you see from this direction, these two, yeah, these two lines are cannot see, and then also this on the bottom or have two lines cannot see or the same thing. So make the dashed line, make this for the composite solid, make this more easy to understand. Yeah. Here, the difference with these two guys, you have any ideas about okay why we have different kind of tools, different kind of pictures of here. The first one we have see here, we have the plane here, but you move the plane, you have it on this direction, then you make the plane have the same position with outside the plane of this of the bottom part here. You means okay, so there is no line. Means what? Means this plane I have the same plane, the same one is one plane, so you do not have a line. You just give the outside limit of this plane. So for these two plane means what? Means no intersection line already. We move the intersection line. So when you drawing, there is no line. So must have no line into uniform surface. So this is the difference. This must have line into deflect surface. This one is a adverse one. We do not have a line to construction here, to construction of another plane on H, on V here. So you guys here we call it uniform. Here. So we do not draw a line here. If you draw a line here, you are wrong. Remember guys, because this is only one plane. Means this plane is only one, not two plane. Yeah. Here, another one is intersecting. From here, you can see this plane and with the curved cylinder plane, you have intersection line here. You should add a line here because it means this plane on the side plane and with this plane is intersection relationship. So you must have a line into intersection surface. One of the surface always we have found is curve plane. But for this one, you just move the plane. Yeah, this plane you move this direction. Make the plane have the tangent. Tangent means what? Means only have okay on the outside. On outside line here, you have give a tangent. If you move this direction, you move this direction means this plane is outside of the cylinder. So you only have the position only on this plane on the most outside on the outside of outside limit of the cylinder. You move it okay, this is a limit time, so means a tangent position. So you do not need to draw a line here. You can see here. No line here. So this is the difference with the tangent and intersection. If for the intersection, the line here and these two lines, you must draw it. But for the tangent, okay, you know nice. Remember this one? Okay. So here is must have no line into tangent surface. So for the for this four relationship of two planes, you'll find this is very interesting. Yeah. Here, when we do the composite solid, you should use the primitive decompounding method or geometric breakdown. So here, we already know, because this is a composite solid, the one of the characteristic of this solid or one of the important feature of this solid is too complicated. Means okay, means this one can construction or consist by different parts of the solid. Get a more complete one, so this is more confused. If you want to do the construction or just do the projection in your brain, you guys you use the primitive decompounding method. So this is advanced process procedures of the compounding. You compounding means okay, you combine them together. Decompounding means what? Means make them into different parts. So here we just show you guys. Here we have a composite solid here. You can change it or just you can make a decompounding position of this cylinder, you can get a how can get how many parts of this one. You firstly get a cylinder, yeah, hollow cylinder here. This is part one, and then you get a ribs or just a handful, and this is motherboard on the bottom, and on the side we have the ribs. So how can you get a very clear or just a quick uh, method to do a projection of composite solid? So this one is very interesting. So you should do a advanced procedure with the compounding method. So you want to do a quickly drawing and also quickly understanding of the views. In the in our drawing class, we should always put the composite solid, and then you think if this one you can put this one into how many parts, and then you use the small part get the shape more clearly. Then you combine them together, so you get the position of these this different parts, and also the surface and the surface different inter relationship positions. So we call this method is primitive decompounding method. Okay, just like here, you can show in this picture. First, you use a cutting, subtraction to get the surface like here. Use a union. 1, 2, 3, you union them together, adding them together, you get the scale, get scale. So this one is always a very similar composite solid in our real life, just like you can get sitting in a theater or just in the cinema film, you want to see a film or cinema, always use the scale like this one. 1, 2, 3, 4, you add them together, so you get a composite solid in the real life, very easy. So when you go to the shopping or just go for a trip, go for walking, you should know that the basic solid is very easy. But when you combine them together, so it's more complicated. So how can you get a composite one into a easy one? You use the decompounding. Just like here, you can see, this solid, we can change them into how many parts. You guys have any idea? So different kind of parts, you can know the projection of this small one. You combine them together, so you can get a composite solid projection very quickly. So here, you can see 1, 2, 3, 4. 1, 2, 3. Yeah, 1, 2, 3, 4, 5 parts, and then you make the relative position and the intersection position of this 5 parts. You can get the reading of the composite solid here. Just like here, you can see this one is a very similar one, which you always see in in a big building. We can see the just like the pipe, or just like the cylinder. Okay, supporter is a supporter, supporter to support the ceiling, just like a prism in your house. You can use this one to uh okay. You can't see my mouse. It's too small. Okay, we use this one. Okay, so this one, okay, you will find this. You can use cutting and union to construction this one. So first you can change, okay, you know the motherboard on the bottom and the ribs. Two kind of ribs, kind one, type two, yeah, and another one is a prism. You make them on the middle of this one, so you get a solid here, yeah, solid here. So in the third part of this question, or of the solid composite solid, we use the mm, primitive element primitive decomposing method. This is one of the methods to do the composite reading and drawing. So another one, we use element method to help combine the primitive together. We have this is the two kind of method to do the composite solid reading, understanding, and drawing. Okay, so here, please know that the element method means what? Means in the solid we have line, point, and plane. You can find the different plane and the different line in the space have the different position. So you can see here, so you can get the which plane is belong to H, on which plane is belong to V, and on H plane, this plane is on which position, and the same thing. You can find the elements in the basic solid or in the composite solid to know the different projection position of this element of this different kind of elements. We call this is element method. So in the primitive decompounding method, we always put the solid into, okay, we want to small down or just simplify it down to get a different kind of basic solid. And you can have different kind of line and plane, and also know the position characteristic of this line and plane and point. So you can use your brain, you can find or use the imagination to know, okay, which one is belong to which plane in the under the real position in the projection of here, so you can find, okay, combining the and know the exact way, so you can draw it in the picture by yourself. So here you look at here, this one is in your brain you will find this plane, this one in the 3D, or how about this solid in 3D in your brain? You can think it's just like, okay, like this direction, and okay, we have the top one here, and the backboard is the shape of this one, and in the on H is this surface. So here we call it the top and the bottom plane. Top plane is on the top, is this one, yeah, is this one, and also combine this one. So you can find there is no line here between this one plane, means, okay, this plane and this plane, this plane and the plane have the uniform position, yeah, so there is no line. But okay, this plane and with this plane is intersection plane, so we have intersection line here on this direction, so there is intersection line. So in the front, middle, and behind plane, this is front plane is and this one, yeah, this is this one, and this is also front plane is this one. This is the middle plane. The back plane is this two plane here and here. So you can find, okay, different kind of plane on H, on V, and on W projection. You will find the relative position on different kind of projection. We call it element method. Just like here, we have C, okay, we have intersecting plane. You can see, guys, okay, the same plane on H, on V is here, yeah, this one and this one is same one, but on H is different one, yeah, just like here. So only one projection is not enough to construction a 3D composite solid. We have we use different kind or two or three a projection plane can construction a unique one. Here you can see the difference on H is different because, okay, on V is the same one and this one, but on H is different one. So we have, okay, on this direction we found that this one we use not the straight line and straight line or just a perpendicular line with this plane. We also incline line to cutting on the shape, to cutting a inclined plane. This one is cutting a spatial plane. Okay, this cutting here and direction and perpendicular direction, we get another cutting to make the same on H on V have the same projection. And this one also, okay, you can see this plane is this plane. Yeah, this is a right plane. This is left plane. Left is direction. This one is left. This direction is left. This one is right. Yeah. So you can always find for the element method, you should find this plane is this one. H is this one. Yeah. The outside of this one is the of here, and the back one, the bottom one is here. So you should okay in H which plane on V is where the position only exact where is the position on the three projection system for one plane or two plane or line. You should do the element method to make a more detailed projection checking. Yeah, okay, we'll see here. Okay, for the projection of the spatial plane, we know the exact plane and also know the accumulation. Here, for the horizontal plane, we can find in the three-dimensional solid projection. This is a composite solid. In the horizontal plane is for the green one. In H is horizontal plane. Here is a line, and here we also is a line. Here line is there. You find on H is here. On V is a line here. And on W there is wrong. On W is this line, yeah. On W is this line. So this picture is wrong. On W is this line and this line, yeah. So on another two projection line and on another plane is a plane. So we call it horizontal plane. Is parallel plane, parallel to H. So the green one is a true size, yeah, true shape. So you can know the true shape from the spatial planes. But for the red one, we call it front plane. Front plane means parallel to the front projection plane. So in this one, the projection is there. So how about in H? This projection is this line, yeah? Is this line. For this one, is projection is this only and this line. So use the element method to tell the which plane is belong to which plane and which plane on where on the different kinds of projection plane. Three different three projection plane. This is the front plane in the okay. Always for the basic solid, we have found the spatial plane very easy. And this kind of question will take in the final examination. So you guys remember to try your best understanding. Okay, which plane is horizontal plane? Which one is front plane? Which one is side plane? So here we can also find the side plane is on this direction. So side plane means on side projection. W is the true size. On this one is a line on here. On this one is line on here. And this one is line on here. Yeah, remember. So you can find the plane and also find the projection of this plane. Another one for the edge view plane similarity. For sometimes we have get a perpendicular plane with another projection plane. So just on the perpendicular plane, most of the time we have the similarity with the real shape of the plane. Just like here, you can see a red one. Red one call it perpendicular to V, because on V, all the projection on V is accumulated to one line. But on H and on W is par is different complicated shape. Yeah. So here we can see this picture and this picture is similar to the real space here. But this one is also perpendicular to V to W. Perpendicular to W. Okay, on this direction, get a perpendicular on V and on H as similar for the shape. Yeah. So this one is perpendicular to H on V and on W also have the similar size. Here we get a projection. This is a inclined plane. Yeah, you guys remember inclined plane because in all three planes are inclined plane. No spatial low low accumulate one line or point. So this plane is an inclined plane. Inclined plane also have some similar shape in the three different kinds three projection here. So we call this one is front edge plane. Perpendicular to V edge to perpendicular to front plane. This is horizontal edge view means this plane is perpendicular to edge projection plane. Side edge plane is on side to perpendicular to side plane. Oblique plane. Okay. So we have different kinds of planes. They have indoor when you do the projection, they have the similarity. You can see from this picture view, and you can easily to get understand the question here. So when you composite solid here, you how can do the drawing steps? Just you want to draw a solid like here. So decompounding the solid together with this one. So first you're decompounding the primitive first step to decompounding them into your basic part, small part, or easy part. Yeah. Then you do the analysis or know the relationship between this small parts. You should do the relative position of this one. Yeah. Then you get the views selection. Views means what? Means you put on H, put on V, and put on W. We have three projection view system. Yeah. Then you select the front view first. A pose of solid put in the right place. You put the suitable place in your draw paper, your white paper. Then your direction of the right represent more properties. Share position and projection direction. You get the different kind of parts you can draw it together. Then you add views complete one by one. How about the drawing steps? First, selecting the scales. So here we should tell you guys scales means what? Okay, Scales means what? Means a factor. Means a factor to do the scale down or scale up. So if you draw a big building, just like this building, it's 100 meter length, but in your paper always is 100 millimeter, 100 centimeter. Yeah. So how can use a small paper to representing a huge building? We use scale. So it means okay, we want to use the scale 1 to 100. Means in the paper, in your small paper, 1 millimeter or 1 centimeter represent 100 centimeter in the real life. So scale is very important because we cannot draw a very big building in only a paper. So use the scaling. You tell guys 1 centimeter represents 100, so the scale is 1 to 100. If you make a more huger, larger and larger building, you can use 100, 1,000, and 110,000. Okay, it's based on your size of the composite solid here. So first you should select a scale, and then your drawing area. You use the drawing area. Just you have the limits of this drawing. You may put them into a proper position for your drawing. Then you draw a baseline. Baseline means what? Okay, means okay means this direction of your decompounding. You make most of the time for the baseline is the bottom part and the top part. Yeah, to get the just like the uh shape or the outside size of the solid. Then you make more details, do more details, do more careful drawing to get the three projection of the basic solid. Then you draw solid on each view in the line. First you draw in line. Then you check them, draw and move the your assistant line, move them away. Or you just do the commit, revise the picture. So you get then you find this one is correct. Is the real things you see in the real life. You can get the projection on the 2D plane and have the suitable scale factor. Then you finish all of them. You check and draw in a achieve line. Achieve line will use the seek line. Yeah, because the first you do not you miss maybe you have to do the check. Yeah, before the check, after the check, maybe you revise your uh drawing picture. So you remove them away, remove then all the extra line. Do not need them again. Then you do the complete and know the exact one. You do the seek line in the last step. Example how can draw a composite solid on views. First, you can see here. Selected scales, drawing area. Drawing area, this one is drawing area, yeah. And then the drawing baseline. This is baseline. And this is baseline. And this is baseline. Yeah. You make a baseline to get the outside of this one on the bottom one. You from bottom to top to join it together. Then you join the motherboard. Motherboard is very easy, yeah. This one is motherboard. You join the bearing. Bearing is on the back side here. Join the ribs is there, yeah. Join the platform is here. It's a hollow cylinder. Complete the detail. Detail is here. Also have the upside. We have also have a cylinder, and check and achieved. So here we have the primitive method for this one. The 1, 2, 3, 4, 1, 2, 3, 4, 5. 5 parts do the decompounding. Yeah, you complete this one. You have the picture of this one. You should draw the projection of this 3 quickly as you can, as quickly as you can. This is for the composite solid, you guys. Okay. Then we will show you. Okay, this one is very interesting for this one. So okay, when we know the scale, yeah, already know the scales. You can see the projection of this one. You'll find the different kind. This one is on H projection. This one is on V projection, and this one is on W projection. So before we move to the next part, and I will show you. Okay, you should finish homework just on the exercise on the class. I will show you. You know, okay, how can do the decompounding? Just use the method on here. I'll show you. Okay, we have any some one question for you to one practice. You draw in your paper, draw it by yourself. You should do it by yourself in the exercise in class, because we will take this kind of question in your final examination. You should do it right now. If I have any question, you can tell me. Then we will show you the answer. Maybe we'll take how many 15 minutes to take this exercise by yourself. You should draw it in your paper now. Remember? I will. Okay, yeah, because I just to did not share the screen to you. I will show you guys. The question in the WeChat group. This is a question for your exercise in class. Draw it. Okay, draw it in your draft paper. In your white paper. Okay. In this question, you can see, okay, this is a composite solid. You use the scale 1 to 1 to draw a three-view projection, three projection on H, on V, and on W. And the unit is millimeter. Although, yeah, this one is 21 millimeter. Use the ruler to get the length. Draw in a. The scale means what? Means 1 to 1 means no scale. Yeah, 1 to 1. Remember, 1 to 1 is no scale. It's the same one. Okay, you draw it by yourself. 15 minutes. You can, if you draw it, you send your answer into WeChat group. Well, okay, 15 minutes later we come back to tell you the question answer. So this question is it's very important. You should draw it by yourself because we will take this kind of exercise in our final examination. So you guys take your times to do the practice. In 50 minutes, we will come back to the class again. Okay, so you first you take your pencil to draw it in your paper. Okay. It's the same thing with this one. Yeah, the same thing with this one. The scale we are talk about is 1 to 1. No scale. The unit is millimeter. Same thing with this one. Yeah, you can Try your best to draw it. Complete one. Okay, so do you have any guys finish? You can send me your answer in the WeChat group. We want to check it. If you finish, if you're understanding what, how can do the decompounding and also for the basic for the compounding solid projection. Any guys, you finish? If you didn't finish it 100%, if you finish part of them, you also can take the picture and then send me or send in the WeChat group to show you guys any answer and any questions, any errors you have draw it by yourself. You have any question or don't understanding what you, how can how to do it for this one for the question number one. Mm-hmm. Yeah. Yeah. I will receive your answer. Ji An Ni. Yeah, your Chinese name. It's a beautiful name. Yeah. So okay. Don't make it, you have some. Yeah. Why? Okay. So I'll show you the correct answer. Wait for a minute. Give you the answer. You follow the answer, you guys, you should try to understanding why we check this one. Because in the real construction, most of the time you draw the projection just like shape of those kind of basic composite solid. So this is very important for you guys to take your practice, take your exercise, and to get the skills to quickly to composite and decompounding together to combine them together to get the projection of this solid as quick as you can. So we have the this one. Okay, we'll find the answer for you. It will take maybe several couple of weeks, couple of minutes. So the answer is you should know the the relationship of V sides belong to H, then display on V is what kind of shape one by one. Then you do the decompounding in the first step. Then you use the element method to get the answer. Okay. Mm-hmm. Yeah, but there's some also have some error mistake here. Not sure. Yeah, you're right. I will show you. Okay, because I stopped the screen share. No problems. This is answer. So the answer showing in the WeChat group you can see here, and yeah, you can see the question is there. You can see the answer is there. You don't can here, so you can compare with this answer and also compare with your question with your own answer. Have the First, we can see this question here. You can see, okay, you can see this is a composite solid. You can make this one three parts. Part one is on the ribs here, and part two, the motherboard on the bottom, and part three is the bearing board on the back. So when you draw how can you draw it? The first step, you can draw the motherboard first. On H, the motherboard is outside line. Then most of you guys will get the answer. Yeah, your answer is wrong. Is correct for the outside? Okay, outside of this one also have the your question is wrong. Yeah, is correct. The outside of this one, but how about the position? This line you is wrong. This line is this one. This line is not this line. This line is also have the wrong position here. You should use the ruler next. Yeah, you can get back to further question answer if correct of yours. So first you draw the bed, and then this one is cutting the small one here. Then you get a small projection here, and on this one, and this line is the same line with on this one. Why you get a question answer? There is a gap, no gap. Gap. You can see from this picture. Also, you can use your position here. You can no gap here. This is nine them together same way. Okay. So and the wrong thing is that okay on the side one. This one is this one, yeah, and this one is the here. The bottom one is here. You can see. Look at this direction. You can see the answer. Please, okay. This one you should do more practice. First time when you do the drawing for the composite solid, in your projection, maybe you find it's not easy, but you do it one by one and practice the question in. I will show you in the homework. You do it, then you get the answer quickly as you can. So I wish you and thank you for you two guys send me your homework exercise. If another guy or I do not know why you if you have any question for this one because this one is it's important for the final examination. So I should tell you guys okay this one is very you should practice by yourself in your homeworks. So okay so today we are going to finish this one and I will have not a homework just to show this is the answer question for this one. You should find the yeah 1 2 3 4 5 1 2 3 4 5 6 yeah 6 1 oh and on this one is also a different kind of scale. This scale is 1 to 2 means all the lengths you should divide by 2. This one is 1 to 5 all the lengths on this one you should divide by 5. So you should know the scales of this one is make this projection more smaller than the real size. Okay, so this one I will show you, and you maybe find the answer by yourself. Then you can get the question quickly. So today we'll move a direction to the another part of this class. We talk about and for the dimension. I know it. Okay, for the dimension is there. Dimension is there. Okay, when you tell another one, you should know that's okay. So should tell the size or just the shape of the composite solid. So this one we call it the dimension on a composite solid. This is limit or specification for the projection of a basic solid. That's it's very important for you. The graphic end title on engineering drawing describes shape and the position of different parts on the basic solid, on the composite solid. So dimension and notes. Dimension and with notes describe size and necessary manufacturing or working process for the instructor. So here in the picture, you will see, okay, in this one we can see the dimension. We can also use the symbol, just letter R. Yeah, we use R and phi to represent the diameter and the semi-diameter. Yeah. So this one use R is semi-diameter. Yeah, is semi one. So this one is diameter. Yeah, phi is the length of the diameter of the circle. And this length we use, okay, we call this one for watch. And you can see for the dimension, we have the, yeah, this one is show the outside or just the limit of the length. And on the arrow, and I have arrow to know the direction of this length and get the length, use the note. Yeah, use a note to show you, okay, this one is 60. Yeah, on H, on V, and on H, on V, and on W. So we have, okay, for the dimension is there. So first, how can you do the dimension? And for the dimension, we have different kind of demand. So first, the basic demand for the dimension, we should know, you guys. First one is should correctly. So this is for the also for the some question you show you for the basic solid projection in the first question I send you guys in the WeChat group. If we draw it wrong, you should find this is very interesting. When you use your projection, it's a wrong projection. You use the wrong projection to do the construction. You will find that this is very necessary. It's wrong. You cannot get a solid in the correct ones. So the dimension is the same thing. You should do the correctly. So it's very correct. All the projection dimension and also the note should be correct. Here, true size, even scaled in drawing. Final stage or final size must be according with the standard of drawing. You should first you should for the dimension you should follow the specification for different kind of industry and also for different kind of country. The second one you should size all parts. You cannot miss any part of the size. You should give the size of the all parts, even though the small parts. So this one is very interesting. So you should complete, make a 100% size dimension, 100% dimension, no miss anything in the size. All shapes of every part must have dimension and not be complicated or superfluous in form of line, linear, distance, angles, or notes. Yeah. Also clearly, yeah, you should clearly here. You should make this one more clear. Clear means what? Means you should have a clear layout for the dimension. You layout, put a layout. Just like for the dimension, we will tell you. Okay, so dimension is composed by different kinds of parts. First, dimension line. Dimension line is a line here, is a thin line, dark, solid line, and determined by arrow head. So the direction is an arrow to give the direction, which indicates the direction and extending a dimension. This one we call is the extended of a dimension. This arrow, and this is a dimension line. Yeah, this line is dimension line. Is dimension line, and the arrow is a extending of dimension. Extending line is the here this line. Extending line means the limit of the line, the outside and the outline of the line. And the text on the dimension line will always to write on the top or write on the left. This is on the left. This is on the top. You write on the this is on the right. Yeah. Also give the text the real size of the meter and the unit always millimeter. Shape describe the shape in size. So you have to tell you guys we call it shape size means okay the large size on this direction and the tallest on this direction and the widest on here. So we have three shape size. Shape size means what? Describe the shape in size. So always means the outside line of the projection. And also we have each part of the solid, we have the position shape. Just like okay, just like this one, you tell the position that this hole in this part the position is on this line. So the lighting 4 is a position to determine the position of the hole. So we call this is a position diameter. Total is outline size of the solid. Base. Base means what? Base means okay, you from this is the beginning direction. On this direction, you use this base to give the just like here. This one is the baseline. Use this direction to length the width of this part. All the dimensions should use this line to make this line is the beginning line to make the to do the width. Just like this is tallest, we can use this direction. This line is the baseline. So from this question, we'll show you guys for the dimension. For dimension, we have the shape, we have the total line and the base for the okay. For this one. So you can see for the dimension, we make the demand for this one supposed to correct, and then size of all parts. You cannot miss any part. You should make this clearly. Just to show this example here, the all the parts, just like all the shape, just like shape 1, shape 2, shape 3, and also some make the dimension line and the extending of a line. So the dimension line is here, and the extending the line is the arrow, and the extension line is this. Yeah, is this line, and then we can make the on the to write the text, and then this are the different kinds of dimensions. So first we can use dimension to tell the shape, and some dimension tell the position, and also have the total, this outline size position. Then have the one direction, use one direction as a base to do the dimension direction. So all the this direction is the base direction. So you all the wireless use this line to as the beginning to do the dimension for wireless. So we have okay shape dimension, position dimension, total dimension, and base dimension. We have 4 different kind of dimension types. So here, it's the same thing. You should obey the specification just for China. We have the GBT 1001 to 2001. We have, yeah, this is for the specification granted number to do the, yeah, to do the specification to obey the national China specification. And also should complete do the, yeah, dimension to have the complete. You should to tell the whole size and of this e-terms, and you do not missing and do not do the repeat. Do not repeat the size and make this so also for the, yeah, primitive dimension. First, you, okay, for the primitive, you always tell the wireless tallness here. You can see if you know here, you do not need to add a dimension on this one. Why? Do not need a, because this dimension is equal to this one. You do not repeat, yeah, repeat any dimension because you always know the length. This length is equal to this length. So your dimension here is okay. You do not dimension 2 times of this length on different kind of projection. Here we do the dimension is same thing. Here this one is for A and this one is for Z and I have 3, yeah. This Y is equal to this one. Yeah. Here is for the some basic solid that dimension. So this one is for H. This one is for H, and this one is for this one. Yeah. You should know the different kind of dimension is there. So this phi is for the diameter of here. Also that phi diameter is there. And another phi. Yeah. Phi 1, phi 2. And this is S phi. This is the different kind of size shape. To in circle, you should use the symbol S phi to give the tell the people this is the diameter here. Okay, for the shape dimension, we should know the shape dimension. Here is the tallest here, tallest of this part, and the wireless of this hole, and another is the wireless of here. So shape size tell you guys, okay, how about the shape? Just like phi, just like phi is a shape size, yeah. Phi tell you, okay, this is a cylinder. Example is there. Yeah, this one is a shape outside like 14, and tell you guys the outside of this motherboard. And then the phi is diameter of this one, and another shape on the edge on this part. Then you can know here, give you different kind of diameter, know you the shape of this question. So just like here, you can use, okay, all the sides. If you from this picture, you give this picture to the construction company, you can obey the dimension can construction this items, this things by this picture. So you do not give this one, you always give this one with the diameter. Okay, you can do the construction or do the manufacturing. Okay. This is also for some special basic, we have to do the, yeah, the prism, we give the 3 basic shape here. And shape 2 here and here. Prism, and then here is also a prism, cylinder, coin, and a sphere. So you can take this picture and find the diameter by yourself. Okay. This we'll skip this one in Chinese. Okay, so we finished the diameter. So then we should do the reading and the drawing and the comprehension. This one is very important. We will know that you should combine those together to know the 3 dimension of this part. So first you can see Okay, if I give you three projection on this picture, you should know the three-dimensional is what kind of size in the combined three projection together. You can get a three-dimensional question of this one. Here, you should know, okay, the size is like this. So this is a reading, drawing, and comprehending here. To comprehend the object in the space or thinking in the three-dimensional, use the imagination to do the visualization in your brain. Is the base of the constructive and creative imagination. Call it reading, drawing, and visualization. We use the three projection, view projection, or the orthographic projection. You combine them together and to make a three-dimensional size, position, and each terms use the vision imagination. So this is your guys should take the practice or take the exercise to complete this practice. So in the class, we only take maybe 1 hour to show you guys, okay, how can do the reading, drawing, and comprehending, but this is not enough. You should take a couple of weeks or a couple of days to cover the exercise to give you different kind of projection and to the three-dimensional to change them one by one. So the first question I will show you in the WeChat group is the adverbs that process of this one. That one uses 3D to 2D, but this one is a 2D to the 3D. Most of them are to practice your thinking and imagination skills. So first, notice when you do the reading, starting each view relative, not one or two views. This one is very important. So you should obey the rules. Just the number one, you should make them together, combine them together, not only to see only one, because only one is not enough to determine the three-dimensional shape for the composite solid. Okay, you should combine them one, two, them together, just like here. You can see, okay, all the projection on this one, on the side one, is this one, but you can find all the projection of this one and this one. Yeah, it's the green one and the red one. All the projection on V and on H are the same. You can do the projection together. You can find, okay, on this one and on this one and on this direction. On V, sorry, this is V, this is H. So V and H is the same, but on W is not the same. So you should combine not one or two, you combine three together. Three is very is must be your choice. Three projection also have, okay, this one is also have the same V and H, but on the W is not the same. Here is another one. On V and on W are the same, just like here. On V and on W are the same, but on H is not the same. So in these two questions, just these two examples, you will find, okay, V and W are the same. You can find it's very interesting. You cannot just only combine one or two together. You should get another three and get more, combine them together. You knowing the shape, combine them together. You know the shape in the three in the real space here. V view are the same. On V is are the same, but on H are not the same. Okay, you can see, okay, all the projection on this on V are the same, but on H is not the same. Yeah, just in the 3D is just like here, it's like here, it's like here. So if you cannot see a line, because look at this direction, so the bottom line is blocked by the ribs here. You should add a dash line here and then here. You guys should find the three-dimensional in your brain by here. The second notice is just finding the characteristics on views. Yeah. To know the basic shape of solid by characteristics. You first always to use the V to know the okay maybe the appro the approximate shape. Then you do the basic characteristics made on the front view, always on the front view to get the okay. How about the size? It's just like here, just like this direction on you can know. So priority decompounding method in reading. So you also can use the decompounding and drawing geometric breakdown to complex solid to a center number of primitive in your brain, in your mind to thinking. So first you will get a very composite solid. You first step you most of times to do the decompounding first. You join and break down, make a two easy one. So just like here, you're dividing area and finding corresponding ones in views. The compounding the solid primitive. According to the area to the view determine the primitive. And then you can by redrawing the primitive and visualizing the solid together. Supplement by line and area method. Just like here. First, you look at here, you one by one. Okay, you can different kinds of color. The same color means means in three projections they are the same one. So make this one okay. We have one, two, three kind of color. We can have three kind of decompounding this one into three parts. First, on the bottom, you get the motherboard. The shape is like this, and also have two coin, two hole on the board. Yeah, this one you use in your brain, you thinking. And on the black one is a ribs, is a prism. Yeah, 3H prism on here. And on the middle, in the middle, it's just like okay, we have get on this one. Use the projection on here, and on here to get the imagination of this one. So if you only have this one, you can get one part first, second part, and the third part. Then you rejoin them into 3D in your mind. Okay, so show you guys the by some slide. First, you get the bottom one. Bottom one is just like it's here on H and on here. So this is on this board. You can buy yourself. You can combine them together. We have the because the this because this and this code is on the board one. So you can see you should join reimagination. This one is just like this shape. Yeah. And then the second part is the middle part on H, on V, and on here. You should find the projection by yourself in different. So we do the decompounding first, and also we do the element method. Okay, which one is belong to this projection? You should check it by yourself. So you can see okay, oh this one is okay, is this part, and the other part is a small part. We get okay here. Then you rejoin them together. Yeah, you get the answer. So we use this slide to tell you guys, when you do the composite solid projection, we use two kind of question to do the final examination. One is you get the 3D, you give the dimension, then you draw the three projections, and you only have the three projection in your brain. You should reconstruction the three-dimensional in your brain, in your mind to get this question. So here, example, reading the drawing and the visualization is solid. You can take 5 minutes to in your by yourself to construction. Maybe how about this one? How about this one? In the construction. in your mind. You do not draw it in the three-dimensional because it's too difficult to draw this one in the three-dimensional. So, but you can read it by yourself. Use the method we talk about one by one. Yeah, you can do it by yourself. Now, maybe 5 minutes, then we'll come back to give you the answer. Okay, we come back. Uh, First you can see here the shape just like this one. And we talk about when first look at the shape, we use the V projection to tell the shape. You can see on just shape just like here. You can get here and on the here is just like here. You make this patch on the motherboard is on this one. So you first look at here. The motherboard should be just like here. You have a coin in there. So then you get the ribs. Ribs, this is very easy. It's like like here. Yeah, it's this one. But this part, this how about this position? Where is the position? should on the two outside here. You should okay. This one is this one. So in the VW, we give the position of this is on this one and outside here. To get the combine them together, you can find the answer. First, for the green part is this one, yeah. And the second is a supporting board. Supporting board is just like here, yeah, it's here. Then you get a earboard, just like here. Then you get the ribs. Yeah, you can combine them together. You find the answer is here. So this is the procedures, okay, to take them together, synthesizing the solid and visualization together to get the three-dimensional of this one. You can see here. This is for the for the primitive method, but also we can do the element method for this one by studying the some special lines and planes on the surface of solid. By knowing this property, just like shape position to add visualization of solid, is a supplement to primitive decompounding method. So first is the decompounding or just the primitive the compounding method. But you can use your element method to do a helping, to the assistance to add a supplement to get a more detailed, more correct, and more quick. So just like here, element analysis most question you can see just like here. You can see the line, the white line here. If you know the size here and know if I have cutting a line here, you know the spatial position is on the top, so just like here. So all the shape is on this one, is the red one. Yeah, you can know the some spatial already know the size. You can get okay if you don't have this one, you have this one. Yeah, but you cutting them, cutting on this. You can see look at the difference with this one. You cutting here, cutting here. So make this one is this. Yeah, make this one. So this one is the shape of this part. So combine them together with the line and the shape together. Then you call here. You call join hole here. Then you join hole here. Just like step by step, you can find the First you do the plan P. Yeah. Then P is on the is size of here. This is a plane on here. Yeah. The plane P is on the line here and line here. Yeah. This is plane Q. Plane Q is the top. On here is top one. Here. And then you go to the plane R. Plane R is on here, on here. So this is plane R. Plane T is on the side one. Yeah. And then this is plane, another plane. Yeah, on here. So you can combine them together with the plane and the line together on different used or different kinds to combine together to find the composite solid projection. For the question 4, and this one, join the third view by reading given views. This question we will take into the final examination. That's this kind of question. You already know 2 of the projection of a composite solid, then you finish the third one. You guys will find try your best to do it, but this one is too complicated. We do not take a too complicated one into the final examination, but we will take this kind of question. So first, to visualization solid by reading, you should reading this one, and then you draw the missing views on W. You guys can try, maybe 10 minutes to get the answer by in your draft paper. You already know the shape H, V and H. You should complete the W. How can do it by this one? You use the method we talked about in the former one. Yeah, in the former slide. Okay, try your best to do it. I will show you answer Then, after 10 minutes, Okay, we are. I think this is another. It's a difficult question, but you should know the method on the behind this question, and not just to okay, worry about it because we do not take this kind of too complicated ones to into the final examination. We'll give an easy one, but the same thing with this one and with final examination, we have used the same method. Just like here, we already know the two. Yeah, we give the third one. The first step, you should change them how many parts, just to do the decompounding at first. The motherboard is here, the back one here, and also you can see, okay, there is a hole on here. The hole is like here, and this is cutting. In the middle, we have just like here, and cutting one part here, and cutting two part here. Yeah, and in the middle we have a hole here because yeah, this part is very easy. Yeah, this part is just like a shape on here, and then the sequence is this direction. We have two hole here, but in the middle we have different a little bit difficult. We have cutting three, 1, 2, 3, and in the top we drill a hole. Yeah, you do the primitive decompounding analysis. Yeah, so you do it 1, 2, 3, 4. Yeah, this is just in your brain. You should look at here. We step by step to determine the primitive by to show you the answer. The first you can see, okay, we do not have the cutting part 2. We give the, okay, this one is very easy to think in your brain, in your mind. Then you move out in the here, because we have cutting two parts in the back and in the front. We're getting the part 2 moved away, just like here. Just move it in this part, you move it over here. Yeah, you then drill a hole in the lifting part here, drill number 3, and in the bottom, in the top, we drill another hole. So you give the question. This is answer. The primitive 1, primitive 2, primitive 3, and primitive 4. We use the subtracting, yeah, to give the subtracting, just like a difference, to give the composite solid in this basic one. Yeah. So you can use the how can get the third one projection. First you draw the primitive 1, just like here. You give the outside here, we have the hole here. Then you cutting two here, cutting two small parts away. So your answer is there. You cutting through the end is there. So you get the cutting is. Then you drill a hole. A hole is there. Yeah, is there. And you drill another hole is there. You drill a hole. So give this one. So step first, you get this projection on V on W. Then you draw step 1, 2, and step 3, and step 4. One by one to change this one to do the V projection, W projection. So okay. So how about this one? Is also complete the missing view by reading this complete. If you do not have the cut line here, you just think this is very easy. If you do not cut in just like this direction, you can see, okay, this is a shape like this, yeah. It's just like a 7. But you cutting, yeah, you cutting, you do a cutting here. So this one is not the same way this one. So you in your brain, first you look at here and look at here. You cutting from this one, you getting the okay. You cutting in this direction. So you first you complete this one. If you do not cutting, so the size of this one is just like you look at this direction, you get a dash line here. Yeah, you first just like here, then you cutting here, cutting just like here. Yeah, you add like a plant cutting from this direction. So you first, if you do not have cutting, you then you cutting. How about here? Is you line them together and line them together to move this away. Yeah. So this is the answer because you get the cut, you know. So this plane projection on here is a line here, but this plane projection on here is a plane here. So we use we use the element method. We use the plane method to give the question of this one. Yeah. So also this is a little bit difficult for you. And on here also is another missing line here. We talk about if we do not have cutting here, so you get the question is there and is there, there, and there line. Because okay, but you have cutting here, you have a small line is there. I can show you guys it there. So first you have the dashboard line here. You look at this direction can look like this line, so we are dash line. Then you get a cutting on this one, then find the answer. Also have this one. Okay. The first one you can show you move this away. You look at here, this direction is like this. You get the so on like this. So for all the example for this, the three question here, you can go back to the here 1, 2, 3, 4, 5, 6, 6 page of yeah. We will check a exercise. This kind of exercise into your final examination. You guys remember, you just to go direct use okay. This one is the most part you should thinking and taking this one in the imagination to give the I think you give the final part in your brain. Then use the projection on this one and complete the third one. Yeah, you have the imagination in your brain. You also combine just like this plane. This is a plane. Yeah, on here it's just on which part, and this is a plane. This is plane. This plane is okay. Is this one. So you find okay, align with you together, and this is a small one, so you get a line. This line is this line. Yeah, this two plane. So you can get this also have the small bite, just a small bite on this part by element method. And think this one, you combine them together. You see here, this is a top one. But then also you have a line here, look at here, so this is cutting a hole on the mirror, and also cutting a small hole here, the sides there. So you look at this direction, you get the hole 1, hole 2, and the top one is there. You get a hole, yeah, this outside, this line, is blocked by this part, because this part is blocked the line of here, just like have a dash line on this two. And look at this direction, you can see the bottom part of this one. The middle one, the line is no, because this two is a uniform plane. Yeah. So I see this one. I will tell you this one. You can only things you can do is do the exercise to practice your imagination, because we do not have any shortcut, short way to give to your improve of your two projection, then you complete the solo one. You get a two projection already know and get a solo one. That is kind of very interesting thing, also very complicated. you do your practice by yourself. Then we will you one by one, then we'll give you answer. You reading the answer, and then you just like here we have picture here. You get the answer by yourself one by one. You just like this example to very interesting and useful. Use this example to to do the a practice, okay, by yourself. So that is the most interesting thing. And also we take those one into our exercise, into our final examination. Yeah, well, okay. Today we have finished our all the class of our for the descriptive geometric. You guys to finish them till now. So last time, the next week we'll do the review and exercise class for you guys, and also some notice and tips for the final examination. I think you guys can check your homework by yourself, and you can pass the final examination. You have no problems. But if you want to get a higher score, you should do the review carefully and also to go back to the exercise class, find the answer and read the questions. And also in the final examination, we'll give the limits or just the scope of this exercise of the final examination. Will give the scope. We do not check all the questions we learn in this in this courses into the final examination because some are too complicated. It's too complicated. You should in your spare time try by yourself to understand the question. And if you're facing the question in your real working in the future, you should know you have learned this kind of skills. That's the useful skills for the geometric. Yeah, so you can know that's when you come back to do the to pick them up. Then you tell your boss I have already known the geometric descriptive geometry. We have know how can do the projection. So how can draw the projection? Maybe use your pencil, maybe use the software. You already get the skill to do the. Yeah, you will give it a ticket. You get the ticket to attending the always get the ticket to crack to open the door to give the access to the projection drawing by yourself. So wish you uh, find this class is will be useful in your future careers. And I also hope you guys can check your pay attention to the next class. You should guys everyone should check the attention and take participation in the last one. Yes, next week Thursday we will give the last exercise X courses. So that one is very important. You should always take the participation in that one. Okay, so today we finish all of our class and wish you have learned it. And also I will give you some homework and do it by yourself. So today we are finished all the class and see you next time. I see you. Okay, and always also wish you have a nice day. Okay, see you guys next time. 拜拜，谢谢大家，我们今天这堂课就到这儿。Sure, sure. It's not. Well, I will make an easy one. Yeah. You can check the skill. Yeah, you can know the skill, so you know how to do it. But when you're facing a more complicated one, you know, yeah, you should have the ability to find the answer by yourself. Yeah, you always
Laushi,
know how to do it. Yeah.
Laushi, if we get the sample question, that will be helpful for get better marks in exam. Think
Sorry. You
if we get
because.
a sample question, like how the question will be,
Mm-hmm.
so that will be more helpful to get a great result.
Okay. Yeah, yeah. In the next class, we will show you the
Okay,
the
thank you, Laushi.
the question type. The question, yeah. we will tell you how can do the review. You do the review, you can pass it. Okay. So
Okay, Lashi.
okay, thank you all you guys. Do not worry, do
Thank you,
not be
Lashi.
worried. Each time all of you guys passing away. This is the third
Exam is
time.
always worried,
Yeah.
Lashi.
Okay. So we should
Okay.
okay, do not be worried. Okay. Thank you.
Okay, Lashi.
Bye
Thank you so
bye.
much,
Bye
Lashi.
bye. Bye bye.
Bye bye, Lashi.
Bye, bro.
The time is not determined. The final examination. I will. The manager will tell you. Okay. Sorry. I'm
Okay.
missing your question.
Okay, teacher.
Okay. Bye bye.
再见。